uniformly. We say figure 1 shows the effect of magnesium ions on the activity of phosphofructokinase, and you have sort of enzyme activity, magnesium ion concentration. There's this graph. It's treated as if it's an eternal truth, and yet any biochemical experiment you do, they're always different. I've done hundreds in my time. You publish one of them that gives sort of plausibly fits the data, and you say representative results are shown in figure 1. And no two experiments give exactly the same results in any real interesting scientific system, such as those looked at by biochemists and so on. And so I think actually there's vast amounts of data. If scientists dated their results, for example, this would be an elementary move towards recognizing the quality of time. And if one found that sort of all particular kinds of results were dated there, and if scientists all around the world found that, say, on the 12th of September experiments weren't working very well, but they all tended to work on the 15th, this would be very interesting information. Everyone agrees that sunspots, for example, the 11-year cycle affects climatic patterns and growth rings in trees. You can measure it way back. And this is standard science now. I mean, and cosmic ray fluctuations, every year the Earth passes through meteorite clouds. There are all sorts of things that are known to lead, and cosmic rays affect mutation rates, and they're different. And if you do experiments where people have tried to do, some of the Rudolf Steiner people did experiments where they crystallized standard solutions, they crystallized them on different days, the same conditions, and yet the patterns, the dendritic patterns of crystal growth differ from day to day, indicating a kind of quality of time. Now, no normal science would do that, you see, because it's assumed that any day is as good as any other. So there in lab notebooks, if you went to the data's all there. There's tens of thousands, hundreds of thousands of lab notebooks in the world today. And scientists do date their experiments in their notebooks. You keep a daily register of experiments, all dated. Just an examination of lab notebooks would be quite revealing, and it wouldn't even involve new experiments. But as soon as they write up the paper, it's taken out of its temporal context and put into this kind of seemingly timeless context of eternal truth.
Well, this is because science cannot operate without this notion of the restoration of initial conditions. And yet this is a highly unexamined notion. And as all these anecdotal incidents indicate, there is no restoration of initial conditions. All of science is being practiced on an unexamined and apparently false assumption. So a more honest definition of what science is science is the art of studying those phenomena so crude that they can have an apparent restoration of initial conditions. But that leaves out all investment schemes, love affairs, dynastic families, military campaigns, and what have you. None of those can have their initial conditions restored, and those are the things that are really important to us. So it then is correctly seen to be a very limited way of doing intellectual business, having a very narrow spectrum of applications. One way I think of thinking about the difference between ordinary science and what Rupert is trying to do is to think of science as that enterprise of human thought which attempts to state what is possible. What is possible. But out of the very large class of the possible, certain things are going to have to be selected to actually happen, to undergo what Whitehead calls the formality of actually occurring. And an idea like Rupert's is a way of saying, well, here it's the past. The past is the factor which selects against the class of the possible to narrow it into this much narrower class, the class of those things which have actually occurred. Science never talks about how the class of the possible is narrowed into the class of the actually occurring. And yet this is obviously a big question. We don't want to know what's possible. We want to know what's going to happen. We don't want to know what might have happened. We want to know what happened. And so new ways of thinking about causality, new ways of thinking about time, new ways of thinking about the way influence, the influence of form is mitigated into the world of three-dimensional space. Does it come from the past? Does it come from some kind of Platonic never-never land that is a hyperdimension that surrounds apparent space and time? Does it come from the future? Is it like a dynamic attractor? Is it a huge flickering shadow across a lower dimensional landscape that is somehow gathered into itself? These are the kinds of questions that have to be asked to create a new model of time that is empowering of the felt presence of immediate experience. That is the new ground zero of any kind of humane science. The felt presence of the immediate experience of the individual has to be the primary datum of a new science. Otherwise, it isn't going to be a new science. It's just going to be a retread on the old science. Well, it's well after 11 o'clock. Maybe we should pack it in. Thank you very much.